first question is number 15 from section 1.6, and it reads as z raised to the 3/2 minus z raised to the 1/2 is equal to 0. In order to start working with this problem, I would suggest thinking about your power rule for exponents. Okay, we're going to be able to kind of sidestep the fact that we have rational numbers in our exponents by working with this power rule. To refresh your memory, the power rule states that if you have some value raised to an exponent and then you take that value and raise it to an exponent, we can essentially simplify this down by saying that we can multiply the exponents together. So for a more concrete example, if we have 2 to the 5th and then raised it to the 3rd power, we can say that this is 2 raised to the 5 times 3, or simply 2 to the 15th. What I'm going to go ahead and do is kind of play around with this z raised to the 3/2. Now, what you want to try to start getting used to is working with the context clues of your problem. Notice that in your problem you have a z raised to the 1/2. And the question that you should ask yourself is there a way that I can break this 3/2 apart so that I can clearly see a z raised to the 1/2? Now, if you're not quite sure why I'm thinking along these lines, just kind of stick around. Maybe note this question for yourself on your notes, so this way you can quickly provide an answer for it. I know in my experience with notes or with homework as well, if I got stuck on something, if I left a note for myself, it helped me kind of refresh my memory if I took a couple days away from the material and then went back to review it. You never want to find yourself kind of stuck on the same question that you had asked yourself prior. So I can use this power rule and say that z raised to the 3/2 is similar to saying that this is z raised to the 1/2 times 3, which in turn means I can write this as z raised to the 1/2 cubed. So what I'm going to do now is I'm going to rewrite the problem, and I'm going to say that this is z raised to the 1/2 cubed instead of z raised to the 3/2 minus z raised to the 1/2 is equal to 0. Now take a second and kind of think about why I might have done that. Take a look at the first term and take a look at the second term. Do you see that they have a common factor between them? Okay. If you're thinking that it's z raised to the 1/2, you would be correct. So if I remove a z raised to the 1/2 in the first term, then I'm left with a z raised to the 1/2 squared, because I removed one of them. And then I removed all of the z raised to the 1/2 in the second term's position, so I put a 1 there to hold its place. Recall that I do that because if I were to redistribute the z raised to the 1/2 back in, I want to wind up back at the original problem. Okay, so I'm going to continue to simplify this down, so I have my z raised to the 1/2. Note that, again, we can defer to our power rule. If we have a 1/2 times a 2, they will simplify down to a z raised to the first power, or just a z. So here I can kind of calmly look at this and say, okay, I have z raised to the 1/2 can be equal to 0, or z minus 1 is equal to 0. And that's from your product theorem, excuse me. So here we go. We are pretty much about to solve this. So what raised to the 1/2 is equal to 0, or you might be more comfortable saying that this is the square root of z is equal to 0. Recall that you can write a value with a rational as an exponent as a root. In this case, it's a square root. Well, the only thing that you can do here is we can square both sides, and so z is equal to 0. Big surprise. And for the second one, we would add 1 to both sides to cancel out, or to remove the -1 on the left-hand side. And then we have z is equal to 1. So your two solutions are z is equal to 0 or z is equal to 1.